Using the powerful James Webb Space Telescope, researchers at the University of Missouri peered deep into the cosmos and uncovered something completely unexpected: 300 objects far brighter than they should be. Scientists are now referring to these strange objects as candidate galaxies, meaning they might be galaxies positioned at the edge of time itself. If verified, they would challenge current assumptions about how and when galaxies formed in the early universe. Even more surprising, these objects appear to have existed when the universe was only a few 100 million years old. But according to the standard cosmological model, that shouldn't be possible, because during this era, the earliest stars and galaxies were only just beginning to take shape. To pinpoint each of the 300 early galaxy candidates, the scientists used a method known as the dropout technique, which identifies high redshift galaxies by spotting objects that appear in redder wavelengths but disappear in bluer ones. After detecting these sources, the next step is determining whether they might actually be at extremely high redshifts, possibly even farther away than we expect. Historically, scientists believed such bright objects weren't early galaxies at all, but other imposters mimicking them. The lead researchers believe that even if only a handful are confirmed to belong to the early universe, they will force us to rethink existing theories of galactic formation. What could these objects be? The final confirmation will come from spectroscopy, the most dependable tool scientists have, by separating light into its component wavelengths. Similar to a prism forming a rainbow, astronomers can analyze a galaxy's distinct signature. This reveals key information about what we're truly observing. The implications are enormous. If these are fully formed galaxies, our ideas about how matter assembles in the universe may require major revisions. If they're not galaxies at all, we might be looking at an entirely new phenomenon, one that shaped the universe's earliest stages. Before 2022, the most distant galaxy ever observed was GN-Z11, a groundbreaking discovery made by the Hubble Space Telescope. Hubble, with its 2.4-meter mirror and remarkable optics, pushed our vision deep into space, but only to a point. Then the James Webb Space Telescope was launched. Equipped with a massive 6.5-meter mirror and optimized for infrared, the stretched, ancient light emitted by early galaxies, Webb didn't merely extend Hubble's legacy, it shattered its records. During one of JWST's early observation campaigns, a galaxy named JWST was identified. It became the most distant confirmed galaxy, with a redshift of 1432. Redshift, simply put, measures how much a galaxy's light has been stretched by the universe's expansion. The larger the redshift, the older the light. Soon after came another galaxy, informally known as Z14. With a redshift of 1444, it pushed our view even further back in time. And what it looked like stunned astronomers. This galaxy is tiny, only about 500 light-years across, compared to the Milky Way's 100,000. Yet Z14 is incredibly luminous. Galaxies this early should be faint and hard to detect, but not this one. Z14 is bursting with newly formed stars, a rapid-fire stellar nursery in the earliest chapters of cosmic history. But something was missing, something major. There was no sign of a supermassive black hole. Most intensely star-forming galaxies host such a black hole at their center, believed to regulate star formation, shape structure, and drive galactic growth. But Z14 shows no evidence of one. The mysteries didn't stop there. When astronomers used JWST spectrograph to analyze its light, they discovered unusually high levels of nitrogen, a chemical fingerprint similar to what we observe in ancient star clusters around the Milky Way. This suggests Z14 forms stars in extremely dense environments, which is totally unexpected. Galaxies this early should be chemically simple, mostly hydrogen and helium. Yet Z14 hints that multiple generations of stars had already lived and died before it, meaning galactic evolution may have begun far earlier than we believed. This raises a major question: how many more galaxies like Z14 exist? Before JWST, scientists assumed galaxies this early would be exceedingly rare. But now, far more are appearing than anticipated. These ancient bright galaxies, often called little red dots, keep showing up in JWST's surveys. Astronomers think Z14 may hold the record for now, but it might not for long. And that's where things get truly exciting. The deeper we look, the more we discover. And each new finding chips away at long-held assumptions. If galaxies like Z14 formed stars faster, existed in greater numbers, and were chemically richer than once thought possible, what else are we missing? Does this kind of galaxy challenge our cosmological models? In short, yes. Current galaxy formation theories argue these galaxies should be rare, slow-growing, and chemically simple. Z14 is none of those. It is fast, bright, and surprisingly complex. It's not that our models are incorrect, but rather incomplete. Z14 hints that the early universe may have been far more dynamic than we imagined. And this is only the beginning. Later this decade, the Nancy Grace Roman Space Telescope will join JWST in surveying the early cosmos. Roman will scan much larger regions of the sky with exceptional precision. Together, these telescopes could uncover hundreds, perhaps thousands, of galaxies like MOM Z14. Each one would act as a time capsule from an era we are only just beginning to understand. For now, MOM Z14 stands as a milestone, a flicker of light from a universe still finding its footing. But the more we dig into JWST's discoveries, the more the cosmos defies expectations. Some scientists analyzing this data have proposed a bold idea. Our entire universe might exist inside a black hole. New research has highlighted a strange mystery. Most galaxies seem to rotate in the same direction. By examining the lines formed by the peaks in their spiral arms, scientists can determine the direction of their spin. This is surprising because in a truly random universe, galaxy rotation should be evenly split between the two possible directions. According to the study's authors, this unexpected pattern, which contradicts existing cosmological models, could hint that our universe itself lies within a black hole. To understand this, we must consider black hole physics. When matter collapses under gravity to form a black hole, it generates an event horizon, a boundary beyond which nothing escapes, not even light. Anything crossing this boundary is lost forever to an outside observer. Yet what happens inside remains unknown. This is where black hole cosmology, also known as Schwarzschild cosmology, comes into play. It suggests our observable universe might actually be the interior of a black hole formed within a larger parent universe. Now think about the Big Bang. The standard model says the universe began as a singularity, a point of infinite density, much like the center of a black hole. If our universe is the interior of a black hole formed in another universe, then the Big Bang wasn't an explosion in empty space, but the moment matter collapsed into a black hole and created a new universe inside it. This idea carries another implication: every black hole in our universe could be the gateway to another baby universe. It might also explain why fundamental constants appear finely tuned for life. Black holes that generate stable universes could be more likely to reproduce through this cosmic cycle. Scientists think this idea could solve several cosmic mysteries. For example, black holes are known to possess immense entropy, matching the vast information content of our own universe. Another concept that could factor into this scenario is torsion. In extended theories of general relativity, such as Einstein-Cartan theory, torsion accounts for the intrinsic spin of particles and can influence space-time curvature. Some theories propose that this twisting effect could create a repulsive force at extremely high densities, preventing singularities from forming. If true, this means a black hole's core might undergo a big bounce, instead of collapsing infinitely, with the rebound giving rise to a new universe inside. Scientists further suggest that this rapid rebound could be what triggered our own universe's expansion, the event we call the Big Bang. Instead of a singularity exploding from nothing, it might have been the rebirth of matter within a black hole in a parent universe. This theory would radically reshape our understanding of cosmic origins, proposing that universes form in an ongoing self-replicating chain. Another intriguing possibility is that our universe might have a preferred axis. Studies of massive cosmic structures suggest certain alignments in galaxy distribution and motion, instead of pure randomness. This cosmic anisotropy challenges the long-held cosmological principle, which assumes the universe is uniform on large scales. If such a preferred direction exists, it could point to unknown physics, perhaps linked to how our universe formed inside a black hole or how fundamental forces behave on the largest scales. Additionally, the presence of ancient, massive galaxies so soon after the Big Bang continues to challenge our understanding of cosmic evolution. But despite how fascinating the black hole universe idea is, there may also be simpler explanations for some puzzling observations, such as potential errors in earlier measurements, including the rotation speed of the Milky Way itself. Either way, the universe is proving to be far stranger than we ever imagined, and the uneven galactic rotations will likely push astrophysicists to revisit key aspects of how we understand the cosmos. What do you think? Share your thoughts in the comments below. And as always, don't forget to subscribe to Territory, because this is your space.